welcome. This is going to be our classwork help video for the Sigma notation worksheet. The directions for problem number 1 through 6 tell us to rewrite each series as a sum. This brings up an important point that when we write a series with Sigma notation, we often call it a series. And when we write it out with all of the pluses, we call it a sum. I don't see that big a difference. I think you could call this a sum or a series, or what we're about to write, a sum or a series. But that's what they mean when they say to rewrite each series as a sum, is to turn this into sort of a string of addition. All right, so I'm going to start by taking this 1 and plugging it in for k. And so that's going to get me 100 minus 1 plus. All right, and then I just start incrementing up that 1 until I reach my stopping value, which is a 4. So the next one would be 100 minus 2 plus 100 minus 3 plus 100 minus 4, and then we stop there because we've reached our stopping value. And now I can simplify this as 99 plus 98 plus 97 plus 96. And you don't have to actually add this. You can just leave it like that. But I do appreciate that each term in this sequence is simplified to be a complete answer. That's what a multiple choice question would look like. They would have your answer like that. All right, let's try problem number 2. So this would be 3 to the first plus 3 squared plus 3 to the third. And then I'm going to stop once the m value becomes equal to 6. All right, and then you can simplify this as 3 plus 9 plus 27 plus 81 plus 243 plus, what is 3 to the 6th? 729. All right, notice they used m as their variable. You'll see lots of different variables used for our index of summation. K, M, A, lots of different things. All right, let's just try maybe number 6 real quick. So I'm going to go from 1 to 6 for my m values. So, and let's actually see if we can just go straight to the sum, the simplified sum. So 30 minus 1 squared is 29, plus 30 minus 2 squared, well, it's the same as 30 minus 4 is 26, plus 30 minus 3 squared, 21, 30 minus 4 squared, plus 14, 30 minus 5 squared is just 5, plus, so we've done 1, 2, 3, 4, 5. This is our last one because it's got a 6 on top. 30 minus 6 squared, I know that's going to be a negative 6. And plus a negative 6 is fine, or just do a minus 6. All right. Evaluate each arithmetic series described. So we're actually going to add the sum this time. Let's jump right to the hardest one, number 10. We want to go from when n equals 5 to when n equals 14, adding as we go. So, and I'm going to try to do it just out loud again. So 0.6 times 5 plus 2.8 is 5.8. Now, this here kind of works like a slope. So I bet I can get the next number without even plugging it into my calculator. If I plug in a 6, well, I've just increased by 1, so I've added that slope one more time. It's going to be 6.4 plus 7 plus 7.6 plus 8.2. See, now we're going a lot quicker now that we're just doing it in our head. And we recognize that this was basically a linear equation. Now I just got to be careful to get the right number of terms. So I've done n equals 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 would be 11.2. Okay, and now we got to actually add this up. Man, adding that up, I mean, I could do that in my calculator, but I wonder if I can add this up using a formula where you're going to average the first and last numbers. I guess I haven't taught you this formula yet, but you average the first and the last, then you multiply by the number of numbers. So 5.8 plus 11.2 divided by 2. So the average number there is 8.5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. And I got 85. It's kind of a shortcut. I'm going to do it the long way just to make sure that that works. 5.8 plus 6.4 plus 7 plus 7.6 plus 8.2 plus 8.8 plus 9.4 plus 10 plus 10.6 plus 11.2, and I got 85 again. So 85 is the right answer here. There is a way to do it in your calculator too. Maybe we'll save that for the next slideshow since we already did that one 2 different ways. Okay, is there a backside to this? Okay, there's. Determine the number of terms in each arithmetic sequence. So here we don't have the stopping value, but we see what the sum is. So I'm just going to just start this sequence and then see how many terms it takes to get up to 78. So when I plug in a 1, I get an 8. Plus, and then I'm just going to use this like a slope, 10, I'm at 18. Plus 12, plus 14. Let's see if I've getting close, plus 16. Let me add that up real quick. 8 plus 10 plus 12 plus 14. 16, I'm at 60 plus 18, and it took me 1, 2, 3, 4, 5, 6 terms to get there. All right, 3i. So this is going to be 3 plus 6 plus, I plug in a 3 plus 9. Well, this is going to take a little bit longer. Let's see if maybe I can use my shortcut here. So I know that, well, now I think you just got to add this one up. Plus 15. We'll just try to add enough numbers to get close, and then we can like subtract away numbers if we need to. So let's see how close I am. So I'm at 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21. I'm at 84. So I can say, yep, right here I'm at 84. Plus 24 plus 27. Let's see, that's going to get me quite a bit closer. Plus 31. That might do it. Let's see. Plus 24 plus 27 plus 31. I'm at 166. 21. 24, 27. Oh, that's very last number should have been a 30. Adding 3 each time. So yeah, now I'm all the way up to 166. Count up the terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. All right, on to the back. Rewrite each series using sigma notation. So we've got to split this up into a way that we can just see a 1, 2, 3, 4, 5, and 6 in this problem. So I'm going to split this first term into 300 plus 1, plus 300 plus 2, plus 300 plus 3. All right, and so that way everything is changing except for the one number that's increasing by 1 each time. So now I can write this as the sum from n equals 1 to 6 of 300 plus n. Final answer. An alternative way to write this would be to start n at 301, stop n at 306, and just say we wanted to add up n. I think this is a little less elegant, but they both work for this problem. Okay, 4, 16, 64. So I can see this is growing exponentially. Gonna rewrite these with the same base. 4 to the first, plus 4 squared. Yep, this is working. Plus 4 to the third, plus 4 to the fourth, dot, 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 all the way up to 4 to the sixth. All right, so now I'm gonna go from, we'll choose I this time. I equals 1 up to 6 of 4 to the I. And that should give us that sequence back. You can get that one. This one, I think we actually did a very similar one in the PowerPoint. Very similar to that first one. Really similar to that first one. Yeah, I think you can get all of these. Maybe 22 is a little bit more challenging. How I'm going to rewrite these. 4, 2, 4/3, 1, 4 over 5. So let's see. I can kind of see that the denominators are counting up and the numerators are counting down. Let's see if I can rewrite this. Let's turn this into actually the numerators are staying the same. It's a 4 over 1 plus 4 over 2 plus 4 over 3 plus 4 over 4 plus 4 over 5. There we go. What just made it tricky is that these ones were simplified, but now I can see the pattern. This is just the sum from, let's use m equals 1 to 5 of 4 over m. All right, and now on to this last tricky one here. So this one relies on kind of a sophisticated technique that if I want to decrease this number here, I need to add directly to my variable when I do it. So what I'm going to do is I'm going to take 7 away from the bottom. All right, but that means I'm going to have to take 7 away from the top, and I'm going to have to add 7 to each of my variables to like counteract that taking away 7 over here. Because we're starting 7 shorter here, so we increase this by 7. All right, and this is going to give us back this same sequence. So instead of plugging in a 7 first, when we plug in a 0 first, this still just gets reset right to 7. And when we put in the 7 there, we would have gotten an 8. Well, now when we plug in the 0, we get an 8. And it's going to follow that same pattern. Okay, I mean, this is a very tricky problem. Just wanted you to try that one. If you got it, great. If you didn't, don't worry. We'll probably see a few more like this, but nothing this hard on an assessment. All right, have a good rest of your day.